Great. Great. Okay, so I'm going to dive in. I'll just mention, as you can see from the panda up there at the upper left, that I am working for World Wildlife Fund. I'm on WWF US's forest team. It's a relatively new gig for me. I've been with WWF since February, but it's an amazing organization. I know the people there well. I did contract work with them for many years, and it's really exciting to be on board with the largest conservation organization in the world, 6,000 people around the world. I can tell you I do a lot of Zoom meetings, and I often have to get up at ungodly hours, but it's exciting. Yeah, the topic is wood, forest, and embodied carbon. You guys read the blurb. And as you can see from the topics that are listed here, this program, it covers a lot of ground. And it's so much, and the information is so tightly packed in that I have felt obliged to do something that I truly hate to do, and that is I'm going to read from a script. So my apologies for that. I hope it doesn't take anything away. We will have plenty of time for discussion and exchange at the end. So with that disclaimer, I'll jump in. So I don't think it'll be news to any of you that forests are vital for people, wildlife, and a healthy environment. They're home to more plants and animals than any other terrestrial biome. They purify the air we breathe and filter the air we drink. They mitigate flooding by acting as giant sponges, soaking up and gradually releasing rainwater. They build soil and prevent erosion. In short, they're at the heart of the web of life. Forests also play a central role in regulating local and regional climates by creating and cycling rainfall. And at a global level, they're one of the keys to solving the climate crisis, both because they store vast quantities of carbon already and because they have the potential to mitigate global warming by drawing down a significant portion of the excess carbon now in the atmosphere. In a recent report, an environmental group called the Dogwood Alliance notes that forests are the only proven natural system that can safely remove and store enough carbon dioxide to keep global temperature rise below the limit needed to avoid the worst effects of climate change. Forests are engines of carbon sequestration. Because they breathe in CO2 and exhale oxygen, they're commonly referred to as the lungs of the world. Trees use sunlight to convert CO2 to sugar, which is carbon-based and combines with other ingredients to make wood and grow the tree. The chemical composition of wood is about half carbon that will remain safely socked away until the tree dies or is cut down and its wood rots or burns. Because trees sequester carbon and store it in wood, many people promote wood as a climate solution. A prominent example, as we were just talking about, is the recent surge of interest in using wood to construct mid and high-rise buildings, where mass timber products like cross-laminated timber or CLT can substitute for the steel and concrete traditionally used in the structure of taller buildings. For those who don't know, CLT is a very large wood panel made up of multiple layers of softwood lumber stacked at right angles and glued together. CLT panels are engineered and made to specification in the factory for a given project and shipped to the job site where the building is assembled, kind of like Legos. The core rationale behind the promotion of mass timber products is that substituting wood for steel and concrete can reduce a building's embodied carbon. Embodied carbon is calculated by totaling emissions associated with the extraction, manufacturing, transport, use, and disposal of building materials. Given that a huge number of buildings are expected to be constructed in coming decades, reducing their embodied carbon is urgent. And substituting wood for non-renewable materials seems like an obvious way to make progress. The assumption is that if wood displaces concrete, steel, and other energy-intensive materials in building construction, the avoided emissions could be significant. What generally gets left out of considerations of the claimed advantages of wood use, however, is the impact of logging on forest carbon. And much of this program will focus on this critical missing piece, without which the true climate impacts of the production and use of wood products can't be understood. As the name suggests, forest carbon refers to all of the carbon stored in the forest, including what's above ground in live and dead trees and other vegetation, as well as carbon stored below ground in roots and soil. Logging results in losses of forest carbon at all scales, from individual trees to forest stands to entire landscapes. Logging causes the near-term release of much of the carbon stored in trees as roots rot and logging slash, such as branches, leaves, and needles, decomposes or burns. More is lost as the log is processed into wood products and the downfall rots or is burned for power. Only about 1/3 of the carbon in a tree is carried through to the end of the processing chain and stored for the longer term in wood products. When forest stands are logged, there's a loss of carbon stored in soils as well as vegetation. For those not familiar with the term, a stand is a limited and distinct area of forest that is subjected to a specific set of management techniques. The severity of the carbon loss from logging a forest stand depends on its intensity. Clear cutting results in a greater loss than selective harvesting does. The loss is greatest if the forest was mature before it was logged. Replacing old growth with a plantation can result in up to a 60% loss of forest carbon stores that will not be made up over time if, as is typical, the plantation is subsequently re-logged every 40 or 50 years. Also, in the first 15 to 20 years after replanting, a clear-cut stand emits more carbon into the atmosphere than is reabsorbed by the growth of new trees, largely because of the continuing loss of soil carbon. Industrial logging across large areas can be a major source of CO2 to intensively manage tree farms. Logging accounts for 85% of emissions from US forests, more than 5 times those from forest conversion, wind, insects, natural tree mortality, and fire combined. In Oregon, clear-cutting millions of acres since 2000 generated 16 to 32% of total emissions from all sectors, making logging one of the state's biggest carbon polluters. In evaluating the embodied carbon of wood relative to other materials, the tool used to calculate and compare cradle-to-grave emissions is, of course, life cycle assessment, or LCA. This tool typically does not account for any reductions in forest carbon stores that may be caused by logging. Most LCA studies assume that the impact of logging on forest carbon is neutral, the theory being that in managed forestry, emissions and sequestration are generally in balance. Reliable methods for calculating the impacts of logging on forest carbon and factoring them into LCAs for wood products are being pursued, but do not yet exist. The results of LCAs for products are reported in environmental product declarations, or EPDs, and the fact that what happens in the forest is left out of the accounting means that the carbon footprint reported in today's wood EPDs may be wildly inaccurate. Beyond carbon, LCAs and EPDs for wood do not address the actual impacts of logging on all other aspects of forest health, such as wildlife habitat, soil and water quality, etc. And so far, at least, these emissions are not prominently noted in a tool that is touted for its comprehensiveness and transparency. The notion that all wood is forest carbon neutral is a vast oversimplification that ignores the starting condition of the forest and the type of forestry practiced. According to one recent study, depending on the assumptions going into calculations of the carbon footprint of wood, current estimates greatly exaggerated. While the actual benefits of substitution are uncertain, we know for sure that if younger forests are allowed to grow instead of being cut down, emissions of forest carbon will be kept to a minimum, and they will continue to sequester CO2 in ever larger amounts for a very long time. Recently, scientists have begun referring to this process as pro-forestation and are elevating it as one of the safest, most effective, and low-cost approaches to climate change mitigation available. Critically, in the next decade, when the window to avoid runaway climate change is most open, protecting more forests will result in far more avoided emissions and carbon removal than will logging them and turning them into wood products. Pro-forestation is even more important as a climate solution than planting new trees, also known as afforestation, because the latter won't make much of a difference in the next couple of decades when action to avert runaway climate change is most crucial. This is because small trees just don't sequester and store all that much carbon. You may have heard that young trees grow faster than older ones, and this is true. But what really matters isn't the rate of carbon removal, but rather the quantity. A 5-year-old sapling grows fast, but it's so little that the amount of wood it adds every year is comparatively small. A 100-year-old tree grows slower than the sapling, but it's much bigger. So a lower growth rate translates into a larger amount of wood added and carbon stored. Old trees store the most carbon. One study found that in natural forests around the world of all types, half of the carbon is stored in the largest 1% of trees. Another frequently heard argument in the balance as the carbon stored in vegetation peaks and plateaus. Now change gears and look at approaches for an agricultural field where trees are planted. With the old growth, forest carbon starts high and drops steeply when it's logged, while with afforestation, it starts low and builds for several decades. The stand represented here is logged once every 40 years on a sustained yield basis, where tree growth and timber removals are in balance. The level of forest carbon drops with each harvest and then builds back up before the pattern repeats. On that same. However, the picture gets more complicated at the landscape level, where numerous stands are being managed simultaneously. Visualize the managed forest as a bucket and forest carbon as the water inside it. The landscape is made up of multiple stands that have been logged at different times and are in different stages of regrowth. Some are taking up carbon and some are releasing it. The challenge is to determine how all of these offsetting inputs and outputs affect overall carbon stores. And we need to do that to understand the differing effects of different approaches to forest management. As I've noted, carbon stores are highest in old growth forests, also known as primary forests, where there's been no logging. The water in the bucket is at or near the top. This level's never static, however. The bucket has leaks. Trees are constantly dying and rotting, releasing carbon in the atmosphere. But even a leaky bucket can hold water as long as water is being poured into it. At the same time that carbon is being emitted from the forest, it's constantly being absorbed from the atmosphere. As I said before, the amount of water in an old growth bucket will remain fairly constant over time. Oops. When the forest is logged, it impacts both the amount coming into the bucket and the amount leaking out, but the major impact is on the leakiness. The more holes you have, and the bigger they are, the leakier the bucket. And the leakier the bucket, the less carbon it will store. In this analogy, the number of holes represents the frequency of logging, and the size of the holes is related to its intensity or severity. The large clear cuts characteristic of conventional industrial forestry can be pictured as bigger leaks, and the relatively frequent harvests can be pictured as more numerous leaks. On the other hand, less intensive logging, smaller openings that occurs less frequently can be pictured as smaller, less numerous ones. As trees regrow after logging, more carbon gradually flows in, less escapes, and the level in the bucket gradually builds back up. But each time logging recurs, the bucket again gets leakier and the carbon level falls back down. And again, the more intensive and frequent the logging, the farther it will fall and the lower the average level will be. If there is a transition to climate-friendlier forestry, on the other hand, the holes are smaller and less frequent, and the bucket is less leaky. The average level will build up and remain higher so long as the management system is continued. Forest carbon store significantly increased, less atmospheric carbon. As I noted before, roughly a third of the carbon stored in harvested trees is carried over in wood products and can be stored for decades in buildings and other long-lived applications. This too represents a carbon store that can increase over time if the number of wood buildings also increases. And if in fact there are reduced overall emissions as a result of substituting wood for more energy-intensive materials, this substitution benefit will accumulate with time as well. However, any potential gains are offset when logging to produce the wood results in significant net decreases in levels of forest carbon. If, on the other hand, the wood used in building construction comes from improved forestry practices that build up levels of forest carbon, then any substitution benefits that exist will be enhanced. Thus, improving forest management and increasing forest recovery and protection are key to mitigating climate change. The steps we need to take are as follows. First, logging of the world's remaining intact primary forests must cease. Forest carbon stores are highest where there is little or no logging. Therefore, we should permanently protect primary forests, particularly but not limited to those that are the most carbon rich. And in the US, these are mostly found on federal forest lands. Second, protection should be extended to allow for pro-forestation of wide areas of previously logged forests, letting them grow back and recover their ecological and carbon storage potential. In some cases, this process of recovery can be speeded through human intervention aimed at true restoration. Where logging continues, it should become less intensive. For example, selective logging or smaller, more widely distributed clear cuts, and higher levels of retention, which is to say, leaving more live trees behind after a timber harvest. Another key is lengthening rotations, which is to say, the time interval between cuts. Tree plantations should not be established at the expense of natural forests. Because complex forest ecosystems store more carbon than plantations and are more resilient in the face of climate change and fire, many existing plantations should be restored to a more natural condition. And finally, afforestation, planting new trees where there weren't any before, is desirable because it brings carbon benefits and will increase wood supply in the longer term. But as has been noted, it takes decades for newly planted trees to achieve the levels of carbon removal and storage that can be realized much more quickly through pro-forestation and a large-scale transition to climate-friendlier forestry. Reforms such as these would not only improve the management of forest carbon, they would yield numerous other important environmental benefits, including less damage to wildlife habitat, relatively higher ecological complexity and biological diversity conservation in the face of a crisis in extinctions, and reduced negative impacts on soil and water quality. As it happens, what is better for carbon is better for all of the other critical ecosystem values and services forests provide. We can't solve the climate crisis without increasing forest protection. What's left of primary forests in the US are largely on federally owned lands where significant but incomplete conservation agreements have secured some protections. We need to protect them completely. And this is why a growing number of environmentalists are advocating for the creation of a forest carbon reserve on public lands that would identify and protect carbon-dense primary forests, as well as areas suitable for proforestation, restoration, or afforestation. Along with increased protection on public lands, we need to change our approach to working forests on private lands. Climate-friendlier forestry requires a long-term view of forest management and an appreciation for the full array of environmental and social benefits that healthy forests offer. There's a trade-off between maximizing the short-term financial return on managed forests and enhancing the carbon and other environmental benefits of forestry. Unfortunately, our financial system favors quick returns and drives detrimental short-term thinking and practice. Businesses bent on maximizing profit, clear-cut, replant, and log again on short rotations because of the time value of money. Basically, potential future income gets discounted such that $1 today is worth more than $1 tomorrow, and $1 in 50 years is worth a whole lot more than $1 in 100 years. By contrast, climate-friendlier forestry requires a willingness and ability on the part of landowners to defer profits into the future. If they do, it's possible not only to increase carbon stores, but also to increase sustainable timber yields. To illustrate this, here's a graph showing average annual timber growth of a managed Douglas fir forest. The dark gray bar shows that the forest is at peak productivity at about 90 years. Acre for acre, the 90-year-old stand is nearly twice as productive the height of the bars being the productive 4 feet, and then across the x-axis you have the stand age. So why are most private industrial forest landowners cutting the forest before it's most productive? The reason is that we discount the future such that the financially optimal timber harvest falls at about 45 years, yielding a third less timber per acre per year than the forest could be producing. The overarching problem here is that modern industrial timber companies usually have a fiduciary obligation to prioritize return on investment over all else, including timber output. The only forest resource typically valued and monetized is timber. Our markets tend to ignore nearly every other forest value, including carbon storage. Because the greatest barrier to the uptake of climate-friendlier forestry on private lands is financial, any solutions must shift the economics. There are three main ways I can think of to do this. Raise the level of the playing field by strengthening government regulations, incentivize change through policies that price carbon at a level that makes it financially attractive to forest owners to improve, or rewarding it through the marketplace, such as by buying forest carbon credits or sourcing products certified to relatively high standards. We all have an idea of how government regulations work, but pricing carbon as a way to underwrite improvements in forest stewardship is less widely understood. One way to do this is through a cap and trade system like California's. At the most basic level, how this works is you tax polluters and use activities that reduce emissions or remove and store carbon, which can include forest conservation and stewardship. For example, California's cap and trade program imposes limits on the emissions of the state's largest polluters, such as utilities and large industrial plants. Companies that exceed that cap have to purchase carbon credits, and one place they can go to buy them is a landowner who is practicing climate-friendlier forestry. In order to garner carbon credits for sale, forestry operations have to go through a process to become a registered forest carbon project. This includes making long-term, legally binding commitments to forest that will result in increased carbon stores over what would happen at the regulatory floor. And the more carbon stored, the more credits you can sell. So you get paid for creating a less leaky, fuller bucket. For example, a decade ago, an organization called the Redwood Forest Foundation purchased 50,000 acres of forest land in Northern California that had been severely damaged and depleted by past logging. They put the land into a conservation easement that protects the forest in perpetuity. Trees must be allowed to grow to 100 years old before they can be cut, and timber harvests are limited to no more than 3% of the total inventory, which is low enough so the forest will recover. Timber volumes will increase with time, and stores of forest carbon will build up. They were able to register and sell credits for over 3 million tons of carbon that accumulated between 2007 and 2014. Forest certification can be another way to incentivize climate-friendlier forestry. Among the available forest certification systems, the FSC, or Forest Stewardship Council, best reflects and supports climate-friendlier forestry. Among other things, FSC standards protect old growth and require less intensive practices than are permitted by law. An environmental group called EcoTrust fairly recently released a study that compared outcomes under business as usual forestry at the regulatory floor with those of FSC-certified forest in Oregon and Washington. EcoTrust found that FSC always stored more carbon, between 25 and 60% more on average. They also found that FSC could increase yields on a per acre basis, but that this was offset by reduced yields resulting from higher levels of protection. For example, FSC requires wider stream buffers than business as usual in Oregon, taking substantial areas of land out of timber production to protect water quality. Buying FSC certified wood products is the most straightforward way I know of to support climate-friendlier forestry. But in some cases, people find that sourcing FSC isn't practical. If your wood is going to come from conventional forestry, you could still incentivize the change we need by buying carbon credits from registered forest carbon projects. Registries such as the one shown here list a wide variety of projects where credits can be purchased. Another option could be to donate to one of the many good nonprofit organizations that are most active in advancing climate-friendlier forestry. In the West, these include EcoTrust, Sustainable Northwest, Pacific Forest Trust. Both purchases of carbon credits or donations could be tied to the amount of conventional wood you are using in the project. For example, even a small percentage of the wood cost directed to the right organization helps move the dial. Sourcing good wood and supporting climate-friendlier forestry is key, but it's equally important to avoid wood that's tied to forest degradation and destruction, and the very worst wood comes from illegal logging. Is illegal wood being used inadvertently in building construction and elsewhere? It is almost certain, because illegal logging is way more pervasive and the trade in illegal wood much larger than most people think. Particularly if you're using woods harvested in developing countries, products such as plywood, flooring, and the hardwood veneer and lumber used in interior millwork may contain illegal wood. An estimated 50 to 90% of all forestry activities in key producer countries in the tropics is illegal. There's also high rates of illegal logging in Russia and parts of Eastern Europe like Romania and Ukraine. And an estimated 20 to 50% of all timber traded internationally is illegal or high risk of being illegal. And finally, illegal logging in the associated trade in wood products represents the world's third largest transnational crime, only after counterfeiting and drugs, and costs developing countries billions of dollars in lost tax revenue. Illegal logging is a major contributor to deforestation. Loggers build roads into previously inaccessible areas of primary forest in many cases, and they pave the way for conversion of those forests by providing access to farmers and ranchers. Forests that have been robbed of their most valuable timber are much more likely to be burned and converted to other uses than are unlogged or managed forests. This has major consequences for the climate. Deforestation is one of the largest sources of greenhouse gas emissions, contributing up to 20% of the global total. The problems underlying the illegal wood trade are deep-seated and systemic. Illegal wood gets mixed with legal material toward the top of global supply chains at the primary manufacturing, converting logs into primary products level is often where it happens. And once this has happened, it's very hard to detect. Furthermore, current methods most commonly used by law-abiding companies to mitigate the risk of sourcing illegal wood, such as gathering documents or conducting audits, have fundamental weaknesses. Documents are notoriously easy to fake, and auditors, who generally pre-schedule their visits, can pretty easily be duped. Even the best forest certification systems are constrained in their ability to effectively screen out illegal wood. Obviously, this state of affairs poses tough challenges for those who don't want to buy illegal wood. How do you avoid what you can't reliably identify? Well, here's an answer. You can support the development of scientific solutions that resist gaming and are being developed by a global network intent on cracking down on forest crime. This is the goal of a new lead pilot credit that rewards the use of emerging technologies for wood identification and traceability. The folks who designed this credit, which includes World Wildlife Fund, have pioneered a new cutting-edge approach that we call Declare, Map, and Test. The first step is declare. Suppliers provide declarations identifying the wood species and country of origin for all wood products used on a project. The second step is map. Suppliers provide maps that more precisely identify where the timber was harvested. And the final step is test, using scientific techniques to check the information provided in declarations and maps. At the heart of this approach are testing methods that can identify the species and geographic origin of wood products. If wood suppliers are required to declare this information and to back it up with maps of source forests, then these claims can be scientifically assessed. A hurdle to making this approach work is that wood identification testing can only be used to verify declarations of species or origin if you have a reference data library against which results can be compared. So, for example, testing can detect certain stable isotopes in wood whose ratios vary by geography and can be used to determine origin if georeferenced samples of that species have been gathered and tested in advance to provide a basis for comparison. An immense effort is now underway to build libraries of reference data, and the building industry can send a demand signal that supports their expansion. While by itself Declare, Map, and Test can't distinguish wood that's legal from what's illegal, it does create a mechanism for holding wood producers and traders accountable. And accountability is key because law-abiding companies will be highly motivated to pass tests, and their upstream suppliers will therefore be under great pressure to provide good information and not look the other way when offered cheap wood that may be illegal. When combined with other approaches, this is a powerful way to fight crime and support the many honest companies in the wood products industry. Okay, wrapping up, I want to come full circle back to the central question this program set out to answer. Is using wood in building construction a climate solution? There's a simplistic narrative out there that goes more or less as follows. Trees suck carbon out of the air that gets stored each time we log timber and use the wood in buildings and elsewhere. We reduce emissions by substituting this wood for other, more energy-intensive materials. And this process only continues if we keep on logging. The conclusion that follows is that the more we log, the better off we'll be. But hopefully by now it's clear that whether or not using wood will help us solve the climate crisis depends entirely on where the wood comes from, where it does not come from, and how the wood is harvested. A significant increase in wood use that's satisfied by an increase in environmentally harmful logging and contributes to forest degradation and deforestation will only deepen our problems. The key question is, will using more wood result in an overall decrease in atmospheric carbon and an increase in carbon stores? Without great advances in forest protection and stewardship, the answer is almost certainly not. In closing, here's some resources for sourcing wood responsibly, promoting climate-friendlier forestry and avoiding illegal wood. FSC has a great website at buildwithfsc.com that includes the Wood Finder, a tool for connecting with existing suppliers of FSC-certified products. Supplier data is still being entered into this tool, so it's not quite fit for purpose yet, but it will be, so you might want to bookmark it for future use. Other good resources at this website include a Climate Smart Wood group that you can join to stay abreast of things and a continuing education program that's accredited by AIA and GBCI. As for the availability of FSC-certified CLT and other mass timber products, the good news is that many of the manufacturers in North America already have FSC certification for chain of custody. And that means that they have the systems in place to make FSC products if they get an order. The not so great news is that not all of them currently have enough certified raw material to offer FSC products at a competitive price today. So if you want to learn more about these manufacturers and their current capacities, I'm giving you here the contact information for FSC US's West Coast manager, Aubrey McCormick, and a big part of her job is helping folks who are looking for FSC certified products connect with available supply. And she's really getting to know these manufacturers and what they can do, and if there's premiums, what they are. And typically there's going to be a premium because you have to pay more for climate friendlier forestry. Cheapest wood comes from the cheapest, most intensive forestry. And the very cheapest wood comes from illegal logging. So we get what we pay for. If you're interested in learning more about purchasing forest carbon credits, I recommend starting with the Climate Action Reserve website. Among other things, there's an offsets marketplace page where you can find listings of entities that sell these credits. I will say that right now you have to hunt for them, and there needs to be a more straightforward way to find them, such as brokers who manage a portfolio of registered forest carbon projects. And this is something that requires more work and support from the market and hopefully will emerge. And finally, there's a lot out there about illegal logging, but for those interested in advancing best practices for avoiding illegal wood in building construction, definitely check out the Timber Traceability Lead Pilot Credit. And there's a CEU program that goes along with it. And actually, I want to state this a little more strongly. The environmental groups who developed the Declare, Map, and Test approach, including WWF, Environmental Investigation Agency, we are appealing to green building leaders like you to register appropriate projects for this pilot credit. And I will provide technical support at every step of the way. So if you're interested, please reach out to me. And that is it. There is my email, and I really do welcome inquiries. So please go ahead and make a note of it. And yeah, back to you, Ben, Mike, Alice.
Okay, so if we're going to be doing question and answer, you have two ways to ask a question here. The first is to type it into the chat. The second is to just put at the bottom of the participants list, there's a little yes thing. If you have a question, just click yes, and I'll see that, and we can unmute you. There's a question from Alice. I'll read this. Unfortunately, something happened to my computer, so the earlier questions I didn't grab, so maybe Ben could help me. But Alice's question is, do the LCA tools like Athena Tally and EC3 differentiate by wood product sourcing, i.e. CLT from FSC versus conventional? If not, could they, and how could they be done?
Yeah, so that's a great question. So the short answer is no, they don't today. They'd like to, but the methods for calculating the impact on forest carbon of logging and therefore tying a wood product to those impacts are very complicated. They're being pursued, and one approach that FSC and its allies are taking is to look at a geography, so maybe let's say the state of California, and look at what the forest carbon levels are at the regulatory floor, and then look at FSC standards and what the minimum of adhering to FSC standards implies for forest carbon stores. So it's kind of like how you calculate forest carbon credits. There needs to be additionality, and FSC provides additionality. So if you can calculate that additionality by jurisdiction, then you can say that if you're getting an FSC certified product from California, you are getting, there's a delta in the forest carbon impact that could then feed into the LCA for that wood product. And so you would have a non-certified conventional wood EPD, and you could have a different EPD for FSC certified wood. So that, broadly speaking, is an approach that's being pursued. The science behind it, to do it credibly and defensibly, it's complicated and it takes money. So I don't know exactly how fast it's going to happen, but it's the data that everyone wants, and that's well understood. So it's being pursued.
Hey, Jason, would you mind ending your slideshow so we can just switch back to regular video?
I don't mind at all.
Here, I'll light the gallery view. There's a question that came in earlier from, I believe it's pronounced Ehai. What is the useful life of timber, and is it affected by managed forest techniques?
Oh boy. Well, the useful life depends entirely on the product and where it's being used and what conditions it's being subjected to. So it's just a big range. And is it influenced by the forest management? Generally, older trees are higher quality wood that will last longer. We all know that old growth redwood lasts a lot longer than second growth. So arguably, if you're managing a production forest, a working forest on a 80 or 100-year rotation instead of a 40 or 50-year rotation, you'll get wood that lasts a little longer, but I don't think that's the main reason to do this.
Okay. Here's a question from Ben. Are there any recent local exemplary projects you know of and could recommend for us to learn more about?
So there are. The more recent ones, I would contact Aubrey at FSC if you got that information. I'm not tracking this as closely as others. Larry, you may know something. But she actually, a little earlier, sent me a PowerPoint deck that had pictures of a bunch of projects. I know the Microsoft campus is using a bunch of FSC mass timber, and it's in process. Miller Hall has done a couple of mass timber projects out of their Seattle office, and there's folks there who have a lot of experience in this. I'm not thinking offhand of any local projects, but I know that Google has a bunch of stuff in the pipeline. Larry, can you think of anything?
I don't have a list for you, but I think that's right. Sarah Architect has worked for Google in the South Bay. I don't know if they've done work on mass timber, so Sarah Architects might have some too. I have a question, if I can, while I've got you, which is, I listened to that whole CLF webinar, which was interesting, and I learned a lot. But the big question I came away with was, are unmanaged forests better or worse than a well-managed forest? I understand that a badly managed forest is probably the worst thing, where you're clear cutting. What if you're just leaving a tree alone, a forest alone, you're not doing anything to it, and there's dead wood and there's bark beetle, all that stuff's happening in the existing forest?
Right.
Is that better than just leaving it alone than a well-managed forest, or does it really depend?
Yeah, this is a hugely contested issue.
Right.
What I can tell you is that this is probably the most contentious issue right now within the environmental community that works on forests, where there's some people who are like, leave it alone. If there's a fire, let it burn. Net, it'll be better. And other folks in the environmental community saying no, in forests where there's overstocking because of decades of fire suppression, these forests are stressed, they're unhealthy, they're prone to catastrophic wildfire. We should go in and do appropriate thinning. And then they go back and forth. I mean, on the face of it, that sounds really logical, but then an argument that gets made is doing really ecological thinning, where you're not going in and also taking out a bunch of the big trees to pay for it, is expensive. And how do you finance it? And how do you finance it at scale? There are huge areas of forest that are in this condition. Right. Can you really pay to do it over a huge area? And if you do it over a small area, what are the chances that your next fire is going to burn there? Right. Not someplace else. Oh, and you have to redo it after 30 years, 20, 30 years if you continue to suppress fire. And so it's a complicated one, Larry. There's parts of the country that have naturally undergone pro-forestation recovery that aren't prone to fire, and it's happened because of the decline of family farms. Basically, the hardwood region, you go east of the Mississippi, and all these forests have been growing back as agriculture is consolidated in the upper Midwest. Right. So, so there's places where really, if we were just looking at climate change mitigation, if we weren't thinking about where our building material is going to come from and what's the best building material, in a lot of cases, the best thing would be to leave forests alone. But if you're looking at the Western forest where there's fire risk, it gets more complicated. And honestly, I've been trying to figure this out for years now, and I'm still confused. Do
you know of anybody that's pursuing thinning dead or diseased wood for purposes of for timber, not for actually using it? Are people using that kind of wood, or is it uneconomic, basically?
So this is a very hot topic in the CLT world, and there's one manufacturer, and I'm not going to remember which it is, but it's one of the ones on that list that I shared, and I could track it down fairly easily. They're citing a CLT mill, a new CLT mill near Spokane, where there is a lot of this overstock forest. And the nice thing about CLT is that you can use small diameter trees. So you could go out and do real thinning and leave the older trees behind and, clear it out some so it's fire prone. So there's that potential. I mean, then some people are going to come in and say, oh, okay, well, once you've done that thinning, then what happens? You're going to start logging. And depending on how you do the logging, that may be the right thing to do. Right. I mean, we're going to keep using wood, and we just need to produce the wood better.
Right.
And then there are areas where the conclusion that I've arrived at is there's areas where it is best just to leave it alone. It's on the federal lands. That's where the remaining old growth is. It's pretty much been logged out every place else. But in federal lands, in the least accessible areas where we have some primary forest left, and those are inaccessible areas where you do just let it burn. I mean, fire is a natural part of the cycle. What's unnatural is that we've suppressed it.
Right.
And so those forests will actually get healthier if they're allowed to burn.
Right.
Problem is that you let it burn now, and there is this, these high stocking levels. But the science, as I understand it, is even with all the overgrowth, even the big fires, they burn through forest landscapes with mixed intensity. And so there's areas where you have it's been nuked. But then there's right around it is an area that was, all the trees were killed, but you get rapid regeneration. And then there's areas where half the trees are still there. And it's a patchwork, a mosaic. And that's actually very good for biological diversity because there's species that are adapted to all those different conditions.
Mm-hmm.
Apparently, there's a type of forest habitat in the Sierras called a snag forest, which is what results in the first 20 years or so after a really big fire that kills all the trees. And it's there's about 5% as much snag forest as there was historically. And it's a very rich habitat. And spotted owl populations are bigger in the areas surrounding these snag forests because it contains so many of the critters that they eat. So it's complicated, but it's a great question. And there are CLT mills that are being sited in areas where the objective is let's use that material. And there's local environmental groups who are getting in there to try to hammer out agreements where it really will be ecologically appropriate thinning and not, mitigating fire risk as an excuse for the timber industry to go in and log intensively, which happens a lot. And that's the thing that people are scared about.
Yeah. I guess part of my question is looking for, as an architect, I'm always looking for things to do besides just specify FSA wood. We've been doing that for 30 years and we do it on every project. We don't always get it, but we always specify it. Yeah. And are there things that we could do that we're not even thinking about, like this idea of trying to figure out what's the mechanism to go in and manage some forests that are, stuffed full that would do well by taking some of that wood out? Yeah. Is there a way to, as an architect, to support that? I don't really know of a way yet to do that, except maybe support some of the organizations you mentioned, environmental organizations that are trying to do it.
And they are the ones who are working on this and working with manufacturers to try to take this approach. So, we can figure out what that CLT mill is, and I could connect folks with the people who really know and are working on this and are asking this great question. But right now, the reason that, after 25 years, Larry, I'm still saying FSC, is it's the only kind of ready to purpose tool that's a proxy for climate friendlier forestry. And to tie a product directly to it, there isn't another ready tool available. Everything else requires even more work and hassle than FSC sometimes requires. Mm-hmm. And there's just no way around that.
Jason, I've got a couple more questions from the chat. Ehai wants to know, do we know why wood is not so prevalent in high-rise buildings in North America? I read that other developing countries are using wood in multi-story towers. So it's compare and contrast in our country versus the rest of the world.
Yeah, my understanding is a lot of it is code. Maybe someone else knows more about it, but that's my understanding is a big barrier is the building codes and fire considerations. And if you go to any of the organizations that promote mass timber like Woodworks, they have just bazoodles of information as to why mass timber is safe in the event of a fire and all the other benefits and reasons that you should use it. And I know there's a bunch of folks who are actively working on changing codes, and that this has already happened in places like Oregon and Washington. I don't know what the status is here in California, but you know, some folks right here in the Bay Area are very deep into this, who Larry knows, and you know, the folks at Arup come to mind. So that's what I know. I'm certainly not an expert in this area.
Well, what we'll do is we're going to be putting your slides, this recording, and then any useful links from this conversation on a page on our website, which anyone who registered will get that link afterward. So that would be a place for everybody to go and check that out. One other question from Alice. If we were to prioritize policies that could support either afforestation or proforestation, or reforestation, or stopping reforestation, what combination would be the best, and in what order of priority?
Hierarchy. When you're looking at natural climate solutions, which includes forests, but it can also be agriculture and peatland and things like that. And the mitigation hierarchy at the top is protect what's left. So protect what remains of primary forests. That's where the biodiversity is. That's where the carbon is. So, you know, it kind of goes to that list, and that's top. And then where we can do proforestation, we should be doing proforestation as much as possible, because that, again, in the short term, in this, we have like a 12-year window to avoid runaway change. We need as much sucked out of the atmosphere as quickly as possible, and proforestation is a ticket to doing that. So that's the next step of the hierarchy. And then the next step down is responsible management. It's using what we have better. And when it comes to forest management, it's managing to a higher standard than we are today, as high a standard as we can around the world, if we can figure out how to do that. And then, I mean, then there's all the questions around, really important questions that Larry brings up all the time about, you know, how do we minimize material use by focusing on the already built environment? How do we use wood as efficiently as possible? How do we reuse wood? I mean, certainly reclaimed recycled wood is the lowest carbon footprint wood that you can use. So those are all really important considerations. And then planting new trees, you know, this trillion trees thing that everyone's all excited about. I mean, heck, the Republicans are behind it. What's that? Me, people I know, we look at that and we say, oh, we know what they mean. They're going to go in and clear cut, and they're going to plant a whole bunch of trees. And they're going to use public money to do it and pad the pockets of the industries who do that. And that's going to be it. Or else they're going to go in and plant, you know, monoculture, fast-growing exotic species that, you know, aren't any good for biodiversity and are going to suck up all the water. And, you know, if you're going to plant a bunch of trees, it's really important to do it right. And then you start competing with agricultural land. I mean, it's complicated, but I would say the hierarchy is, it's protect what's left, restore what we can, responsible management, and then at the bottom, plant new trees.
The one thing I would say about new trees, Jason, is that one place that it actually would make a huge difference, and is plant new trees in cities.
Oh, yeah.
You could, someone from CMG gave me some figure, and I don't know if it was 1 billion trees, that the amount of trees you could plant in a city, which would both lower global warming, it would lower, you know, heat island effect, all kinds of things, and create more trees. And it's not a place that's going to be, you're not displacing forests or farmland by doing it.
Yeah, all for it. And, you know, certainly it's not an argument against planting trees, but if we're looking at the big picture of how forests and wood can mitigate climate change. Planting a tree today, I mean, it's a great idea. It's just not going to solve our 12-year emergency, because those trees aren't going to be very big in 12 years.
We have a question from Zachary Moore. Is there much illegal forestry in the US compared to internationally?
No, very low levels of illegal logging in the US, Canada, Western Europe. There's a lot of countries where, I mean, there is some, but the risk is low. So this is really a problem primarily in the developing world, where, you know, they have good laws on the books, but they have really crummy enforcement of those laws and high rates of corruption and, yeah, poor governance. And that's where it's really out of control. So this declare, map, and test approach that I talked about, it really makes sense to, like, it's good for, it makes people ask the question, where does the wood come from? I mean, if you're using all domestic wood, don't do it. But you can ask the question, you know, what's in those cabinets? Where is that engineered flooring manufactured? Oh, where does that plywood substrate came from? Oh, guess what? It's birch plywood from Russia. Illegal logging is a big problem in Russia. And a lot of times people don't think about it. And sometimes those imported woods, they're the ones that you see, but in other cases, they're in places where you don't see them, and they're substrates where we use it because it's cheap. So, you know, China is the giant machine for laundering illegal wood in the world today. And there's a lot of cheap wood products coming to the US from China.
Okay, so this is a question from Andrew McCormick. He brings up the fact that the concrete industry has got a very strong lobby, and they tend to lobby against new building innovations such as CLT. Can you talk a little bit about that as one of the pressures upon the adoption of CLT?
I don't have that much to say. I've spent most against the timber lobby. So I'm sure there's other big lobbies.
Larry, do you have any sense about that?
Well, yeah, it was the concrete industry. They funded a study. It was actually a really good study that poked holes in this, the narrative. Use it instead of steel and concrete and all will be well. And so they published a study challenging that on very solid grounds and citing a lot of science and doing some new science. And so, I don't know, there's an example of where the concrete lobby maybe did something that wasn't so bad, but then I'm sure there's a lot of other things that aren't so great. So.
So from Alice, building on Larry's question, is there concern that the popularity of mass timber and CLTs could harm climate change efforts by driving up deforestation of old growth forests?
Yes.
Are we seeing that yet?
Yeah, I mean, in the US, that's honestly probably not so likely to happen because, again, there's so little old growth left. And what old growth there is either in national parks or it's in these remote areas of national forests. So I would say in the US, that's not so much a concern. Where I'm really concerned about that in North America is in the boreal. And trees don't get so big in the boreal. People don't think of that as being old growth necessarily because they're small trees, but it is. And there is a huge amount of carbon being stored in the boreal, and the boreal is being logged. And it's a huge threat. It's a huge threat. And so, yeah, I mean, if CLT, if it just exploded and people started building these CLT plants up there, you know, on the edge of the boreal there, halfway up the Canadian provinces, and it drove, you know, I mean, even if they're replanting trees, again, it's that carbon debt. You're going from that high level of carbon storage, you drop it down when you log, and then it comes up and you log in the near term that we can't afford. We have to go the other direction. That carbon in the atmosphere. even if we're getting some sort of substitution benefit, it makes no sense.
Well, that's all the questions we have in the, oh, here's one from Susie. Where are the primary forests worldwide that are most endangered?
The Amazon, Congo Basin, Sumatra, Borneo, Myanmar, the Russian taiga. You know, there's little patches left, like in the Carpathians and in Romania and Ukraine, Belarus. Those, I think, are the big ones. I might have missed something, but those are the big ones. And there, you know, you're looking at primarily tropical woods, but not exclusively. Like in Russia, it is a lot of birch, and there's just a ton of birch plywood being made in Russia, birch logs going into China, being made into plywood, and a lot of that is coming to the US. Eastern Europe, you know, we're talking oak. Lumber liquidators got busted 4 years ago for buying illegal oak from a Chinese manufacturer that came from the Russian Far East. They said it was coming from Germany, and they did testing and found out that the oak wasn't. They got a tip off, they did the testing, and they nailed them. So, you know, it's mostly tropical wood. If it's not FSC, do not use tropical wood. Just don't do it.
Is there FSC wood coming out of the tropics and out of Russia, out of Eastern Europe? Do they have FSC supplies?
There are.
Okay.
Yep.
Good.
Yep. There is some, but it's a struggle because they're competing against the illegal wood.
Right.
It undercuts the price of everything and makes it very hard to, you know, bear the cost of actually managing the forest. And that's just, it's this vicious cycle. It's very, very tough. There are a lot of people working on it, and there's legislation in the US, the European Union, Australia, Japan, that makes it a crime to import wood that's been illegally logged in the country of origin. And all of that added together is putting pressure on the illegal loggers and traders, but it's still happening. It's so hard to crack down on.
Jason, do you have any, this is an impossible question, but let me ask it anyway. Any way of estimating how much carbon is sequestered by planting new trees versus letting an existing tree grow longer? In other words, what's the difference in those two scenarios? Is one twice as much? Is letting the forest grow longer a plot of land versus planting that whole plot of land with new growth? Is one like twice as much carbon? Does anybody have any figures on that?
Yeah, you can measure it. I mean, it's going to vary.
Has anybody measured it?
And the starting condition of the forest. So if you take a forest that, let's say the average age of the trees is 50 years, and you let it grow for 10 years, it's not going to add as much carbon as a forest that's 80 years, because the trees are bigger, and even though they're growing slower, it's that thing where they're adding more volume. And so, and if we're looking at a 10, 20-year time horizon, you're starting now, and you plant new trees. I mean, some trees grow faster than others. Right. And so, you know, you are going to absorb carbon, and that's a good thing. But it's not going to be as fast as starting with a forest that's, you know, 20-year-old trees or 30-year-old trees.
Right, right.
They just have a jump on the whole thing. One thing that's been shown is that where afforestation makes the most sense today is in the tropics, because the trees grow way faster. And the big issue there is planting the right trees and doing it in the right ways. WWF has a wonderful program to promote responsible plantation establishment and management called Next Generation Plantations. They've got a sweet video and then a lot of underlying information. And there's some amazing work being done. Companies like International Paper and Hewlett-Packard are investing in reforestation efforts in the Atlantic forest of Brazil that combine plantations that can produce pulp for their manufacturing, and combine it with restoration of the actual native forest, and the two are side by side. And a lot of the restored area is along streams where there's the biggest benefit for water quality and water production. Super important. So, you know, it's not a simple thing where plant trees good, you know, plantations good, natural forest bad. It's complicated, and like it says in the presentation, so many times, it depends, right? It just depends. It's not sort of cut and dried, simple. This doesn't, bumper stickers don't work for this, and that's part of the difficulty. You need to have a complicated, nuanced conversation like we're having here.
Mm-hmm. All right, very good.
All right, well, maybe we did it.
Thanks, Jason.
Yeah, well, thanks to all of you. I hope this was valuable. Please do reach out, and reach out to Aubrey if you feel so moved. And see you next time.
Very sobering. Thank you very much, Jason.
Thank
Okay.
you, Jason.
All right.
Thanks for moderating, Larry.
Good night.
Jason.
Good night, everybody.
Yeah, thanks.
Thank you.
Bye.